everyone, and welcome back for our latest deep dive. We always try to focus on the stuff you find most fascinating, and judging by, well, everything, it's clear you're really interested in how we can get AI to think more like us.
It's the million-dollar question, isn't it?
Totally. And this time, we're going beyond just, recognizing images or processing language. We're diving into the really complex stuff, the kind of intelligence that involves understanding how things relate to each other.
Relational reasoning. We take it for granted, but it's a cornerstone of human intelligence.
Exactly. And thankfully, some seriously smart people are working on this, and we've got their research. It's all about a new kind of neural network called a relation network, or RN for short. And let me tell you, this stuff is seriously cool.
What's really interesting is that it addresses a challenge that's been around for ages in AI research. I mean, think about it. A child, even a really young one, can look at a park and just know that those two trees way over there, those would be a great starting line for a race.
It's like it's intuitive for us, but for AI, not so much.
Not so much, no. And that's where those traditional approaches kind of hit a wall. You've got your symbolic AI, good for logic problems and things that follow strict rules, but real life, it's messy.
And then you've got deep learning, which is great at dealing with messy data, but those abstract relationships, those connections, it's like they haven't quite cracked that code.
Exactly.
So where do relation networks fit into all of this? Are they the missing piece of the puzzle?
They might just be. Think about it this way. You've got CNNs, right? Convolutional neural networks, amazing at finding patterns in images. And then you've got RNNs, recurrent neural networks, kings of understanding sequences like language.
Right, each with their specialty.
Precisely. Relation networks are like the new kid on the block, and they specialize in, you guessed it, understanding those crucial relationships.
Okay, so they're all about connections, but how do they actually do that? What's the secret sauce?
Imagine a detective, right? They walk into a crime scene. They're not just looking at each clue in isolation. They're trying to figure out how they connect, how they relate to each other to tell a story.
They're searching for relationships.
Exactly. That's what an RN does. It scans all the possible pairings of objects or even concepts, and it figures out if there's a meaningful relationship there, and if so, what kind.
So it's not just passively processing, it's actively looking for connections. That's amazing.
And it's incredibly efficient. Traditional networks might need to relearn the same relationship multiple times for different objects. An RN learns it once, applies it everywhere. Plus, it understands that cat on the mat and mat under the cat, same relationship, just different ways of saying it. Order invariant.
My mind is officially blown, and this is just the beginning. The research mentions something called the CLEVR dataset. What is that? Some kind of test for these RNs?
You could say that. CLEVR stands for Compositional Language and Elementary Visual Reasoning. It's a data set designed to test how well a machine can understand relationships in visual scenes.
Visual scenes, meaning?
Picture this, images of 3D shapes, cubes, spheres, cylinders, all bright colors. And then questions about them. Is the blue cube larger than the sphere in front of the red cone? That kind of thing. To answer, you need to really understand those spatial relationships. This was a huge stumbling block for older AI models.
So it's like a visual puzzle, but for AI. Did the RNs pass?
They didn't just pass, they aced it. We're talking state-of-the-art accuracy on CLR, even exceeding human performance in some cases. This is groundbreaking stuff because it shows that machines can be taught to reason about these relationships, just like we do, maybe even better.
Hold on, exceeding human performance. Are you serious? That's incredible. So you're telling me AI could actually understand these connections better than we can?
It's a real possibility. But it gets even more exciting. RNs aren't just limited to pictures. Researchers also tested them on tasks that use language, things that require the same kind of relational reasoning, but with words.
So from images to words, are the RNs still holding their own?
Absolutely. They tested them on a data set called BBI, which focuses on text-based question answering. These are complex language problems requiring deduction, induction, the kind of reasoning we use every day.
And ace them too, I bet.
You bet. RNs were on fire. But it gets even cooler. They even tested them on, get this, dynamic physical system.
So now you're just using all the big words to make me feel like I skipped a few grades. What does that even mean, dynamic physical systems?
Imagine like watching a simulation of a bunch of balls bouncing around.
Okay, I'm picturing it.
Right. Some are just bouncing randomly, but some are connected, like by invisible springs or rods. And the RN has to figure out which ones are connected just by watching how they move.
So it's still about understanding relationships, but this time it's relationships in motion. Trippy.
Exactly. It's about reasoning about how things relate to each other, even in a complex, ever-changing environment. And, just to keep you on the edge of your seat,
Don't tell me the RNs aced this too.
aced it. They were able to predict those hidden connections just from the movement. So we're not just talking about static images or text. We're talking about understanding relationships in a way that's closer to how we experience the real world.
It's like AI that can actually keep up with the chaos of, well, reality. Pretty impressive. But the researchers didn't just want to show off how cool RNs are, right? I mean, they had to make sure they were really isolating this relational reasoning ability.
Oh, absolutely. They're scientists, right?
Yeah.
Rigor is the name of the game. So they came up with this really clever data set called, wait for it, sort of C-Livy-R.
Heard of Cliviar, you're kidding.
Nope, that's the actual name. And it's kind of like the C-Livy-R data set we talked about earlier. But it's designed to directly compare how RNs stack up against those traditional networks on both relational questions and non-relational ones.
Head to head. So, was it a clean sweep for the RNs?
Well, here's the thing. The RNs didn't just outperform on everything across the board. They specifically excelled at the questions that required understanding relationships.
So it wasn't just that they were better overall, they were specifically better at this one thing, which is kind of the whole point. Okay, so we've been in the weeds a bit here with the sciencey stuff. But I always want to make sure we bring it back to what it all means for, the person listening to this right now. Why does this matter for them?
That's the golden question, right? And the answer is the potential applications of this technology. Huge and incredibly exciting. Think about robotics for a second. Imagine robots that could actually understand complex instructions, not just like turn left, go straight. Robots that could navigate tricky environments, make judgment calls on the fly.
Like the difference between a robot that can vacuum your living room on a preset path and one that can actually tidy up after, say, you've had friends over for dinner.
Exactly. Understanding that dirty dishes go in the sink, leftovers go in the fridge, that kind of common sense reasoning.
That's some Jetsons level stuff right there. I'm sold.
But it doesn't stop there. Think about how we communicate. Imagine chatbots, virtual assistants, that can actually hold a real conversation. They get what you mean. They understand the nuances, the context.
No more of those chatbot conversations where you just want to scream because they clearly don't understand what you're saying. I feel seen.
Right. Virtual assistants that actually assist. But it goes even beyond that. What about scientific discovery? RNs could analyze huge data sets and find those healing connections, the patterns that might have been invisible to us. Breakthroughs in medicine, climate change, all because we have a tool that can see relationships we might have missed.
It's like giving scientists a superpower. Suddenly they can see things in a whole new light, things that were always there, just hidden in plain sight.
Exactly. The possibilities are pretty much endless.
It really makes you think, doesn't it? About the nature of intelligence itself. I mean, we're talking about a whole new way of solving problems, of understanding the world around us. But as always, I like to leave our listeners with something to ponder, something to maybe spark their own, deep dive. And this research, well, it gives us a lot to chew on.
It really does. I mean, we've seen how these RNs can be taught to understand these complex relationships, sometimes even better than we can. But it makes you wonder, could they actually teach us something about how we think?
Whoa, now that's a mind-blowing thought. It's like we're holding up a mirror to ourselves, using AI to understand our own brains better.
Exactly. By studying how these RNs learn, how they reason, could we discover something new about human cognition, something we never would have found without them? It's kind of a crazy loop when you think about it. We set out to create artificial intelligence and end up with a deeper understanding of our own natural intelligence.
Talk about a plot twist. And on that note, I think we've just about reached the end of our deep dive into the world of relation networks. From how they work to their potential impact on, well, pretty much everything. It's been quite a ride.
It really has. This is definitely a field to watch. The possibilities are, well, pretty much limitless at this point.
Absolutely. Who knows what amazing breakthroughs are on the horizon, right? And with that, that's it for today's episode. As always, thanks for joining us. Keep those brains buzzing, and we'll catch you on the next deep dive.